Okay, hello. Good evening, guys. Uh, Welcome back to our December week 3. Right, this is the last class of our English class, because the week 4 one has already passed this morning. Right, so if you didn't join, okay, I don't think you guys joined, right? So make sure you request video, right? Please make sure you submit your request. Okay, please make sure you submit your request, and I'll send you the video as fast as I can. All right, so what are we doing today? Let's continue with our chapter 11. We're going to finish this today. So last week we did finish what is your displacement, distance, speed, velocity, and your acceleration, right? We finished this, right? So today we are going to go into this part. Okay, we finished ticker timer also, the ticker tape thing, right? So this week, let's continue with our graph, right? This is the most headache part, isn't it? If you learn this in your school, right? Maybe not so much lah, because you learn this in maths also. You learn what is your distance time graph, but in this case, we call it displacement time graph. And we learn what is the velocity time graph or the speed time graph that you have learned. Have you? Have you learned this in school? I hope you have, because your exam is coming soon. So this would be coming in your exam also, I figure. Right, so let's go to our displacement time graph first. This is the most easy one. All right, and before I begin, the gradient of this graph is the velocity. Why? Because gradient is y divided by x. When you have your y as your displacement, x as your time. So y divided by x is displacement divided by time. So displacement divided by time is velocity, right? So the gradient is the velocity. So let's look at what happens in this graph. So for the first 2 seconds, let's imagine this is a car, right? For the first 2 seconds, this is positive gradient. So positive gradient is positive velocity, right? You see, positive gradient, positive velocity, right? So what does it mean by positive velocity? That means the car moves forward, right? Think about it. Okay, think about it. The car moves forward, so that is a positive velocity. Okay, and then next, from the second to the eighth second, so the car is staying flat. So when a line is flat, this is zero gradient, right? This is maths, guys. This is mathematics, So this is zero gradient. When your gradient is zero, your velocity is also zero, since they are equal, right? Zero gradient, zero velocity. So zero velocity, what does it mean? That means the car is not moving anywhere. The car is not moving anywhere. The car stays. So the car moves forward and the car stays. And then the car moves forward again because positive gradient. And then what happens now? Can you see the gradient goes down now? The gradient goes down. So this is negative gradient. Negative gradient means negative velocity. What does it mean by negative velocity? Negative velocity means the car moves backwards. The car moves backward. Okay, so the car moves forward. The car stays. The car moves forward again. The car moves backward. Everything is done with a steady speed, guys. The car just, at this part, the car just goes steady speed, not increasing speed, not accelerating or slower or whatever. Steady speed, you see? Steady speed forward, then stops, then steady speed forward again, then decrease speed. I mean, go forward, go backward. Right? Are you guys okay with that? Are you guys there? Are you guys okay with this? All right, so as you can see here, from O to A, this is uniform and positive velocity. That means it's going forward. And then AB here is 0. So the thing is at rest. And then BC is positive. So it's moving at uniform speed again. And then negative uniform, it turns back to the starting point. But you got BM nodes, oh shit. But can you understand? Can you understand? You might need to request Auntie Teo to send you another one again. If you want to, right? But fortunately, this chapter, there's not much explanation here. So I guess you can still do with BM, I hope. Right, so let's try our exercise, shall we? Let's try our exercise. So this is a displacement time graph. This is what happens to a remote control toy car. What is the displacement of the toy car after first 4 seconds? Right, after first 4 seconds, how long did the car go? How far did the car go? So 4, 6. Right, so in 4 seconds, the car moved 6 meters. Just look at the graph. You don't need to calculate anything here because the graph is displacement graph. Right? We want displacement. Right? Okay, guys, I'm rushing this a little bit because I need to finish this by today. I hope you're okay. So what is the velocity of the toy car from 3rd to 5th second? Right, from 3rd to 5th second, that means here, what is the velocity? So how do you find velocity in the displacement time graph? How do you find the velocity? You find the gradient, right? You find the gradient. So when you find the velocity, you find the gradient. So you are looking for this gradient. So do you still remember how to find gradient? This is your point A, which is 3, 4. This is your point B, which is 5, 8. Remember this? Remember this? And then you have your x1, y1, x2, y2. This is mathematics, guys. So how do you find gradient? It's 8 minus 4 over 5 minus 3. So you have 4 over 2. You have 2 meters per second. Right? That means this gradient here is 2. You guys okay? You guys okay? This is basic maths, Okay, basic mathematics. Right, let's do one more. Let's do one more. So again, displacement time graph. What is the displacement of the motorcycle after 4 seconds? So after 4 seconds, the motorcycle is at 15 meters. Right? So what is the velocity of the motorcycle from the 6th to 12th second? From the 6th to the 12th second. So they want this gradient here. Right? They want this gradient here. Right, so guys, make it a habit. Make it a habit. Whenever you see displacement time graph, write this down. Gradient equals to velocity. Right? Gradient equals to velocity. This helps you a lot, right? Because when they want velocity, what do they want? They want a gradient. So we just look at the gradient. Right? So again, this point is 6, 15. This point is 12, 0. So 0 minus 15 over 12 minus 6. So negative 15 over 6, you get negative 2.5 meter per second. Velocity means speed. Yeah. Because in maths, you learn distance time graph and speed time graph, right? It's the same. It's just that velocity, they use the straight distance. Speed, they use the long distance. Remember last week? Right, so number 3, again, you have the displacement time graph here. What is the displacement made by the object while moving from A to B? Right, from A to B, how much did it move? This would be your 25 meters. Right, 25 meters. Okay, so next, what is the velocity of the object while moving from B to C? Right, from B to C. Again, how do you find velocity? You find the gradient. So what's the gradient here? What's the gradient here? If it is a flat line, gradient is 0. Right? The kecerunan is kosong. There's no cerun because the thing is flat. There's no gradient, no slanting. So it's 0. So velocity while moving from C to D are now, again, they want this gradient. So this is 725. This is 10, 0. So 0 minus 25 over 10 minus 7. So negative 25 over 3. So negative 8.33 meter per second. So far, okay? For you maybe okay lah. Wow, sir, so easy. You wait. When the next graph comes, that's when confusion comes, right? I'm sure you learned this in maths before. So what is the average velocity of the object? So Kavi, you want to know the difference between velocity and speed? Here comes. Right, what is the average velocity? How do you find velocity? How do you find average velocity from here? Since you see the gradient just keeps changing. Okay, what is this? What is velocity? Velocity is displacement divided by time, right? What is the displacement? Displacement is the distance from the starting point straight to the ending point, right? I don't care how much you turn, how far you go. I just want from the starting point to ending point. So if you see here, from the starting point to the ending point, all right, you see what happens to this car? The car moves forward for 25 meters, okay? And then the car stops, and then the car moves backward for 25 meters, right? The displacement is 0. You know why is it 0? Because I end up at the same point. I start here, I end here. Right? So from my starting point to my ending point is 0. I don't care how much you travel because you end up at the same point. So your displacement is still 0. So how much is the total time? The total time is 10. So 0 divided by 10 is 0. You see the difference now? You see the difference now? But if they ask for speed, now it's distance divided by time. Distance is slightly different. Distance is the total. So what's the total? I move forward for 25. I move backward for 25. So the total is 50. Time is 10. So my speed, my average speed is 5 meter per second. My average velocity is 0 meter per second. Right? Do take note of the average. Average, when you see this graph, when they want you to find average, you have to find total divided by total. That's not, you cannot find things from this graph. Right? You have to calculate by this yourself. Okay? Are you guys fine? Are you guys fine? Jala, are you okay? Jala, I've learned this in school, right? I believe you learned this in school, right? And Kavi, have you learned this in school? Have you learned this in school? I bet most of your school finished your syllabus already, right? Oh, guys, this morning, earlier this morning, I finished chapter 12, right? So you guys were not there. I think you guys were not there. So please make sure you request video, Make sure you request video. I will send you video for this morning. Okay, that will be week 4. Okay, anyway, so moving on. Let's go to time, velocity time graph. Okay, this is where things get complicated. So just now, displacement time graph, the gradient is velocity, right? Now we go down some more. So for velocity time graph, the gradient is acceleration. So you see, displacement, velocity, velocity, acceleration. Right? Can you see it goes down? And then now we have to look at the area too. Because the area is now the displacement. Oh, crash account, it's okay, it's okay. As long as you request, remember to request. Okay, so area is displacement, right? This is, I think you learned this in maths lah. Exactly same like this. Right, so let's understand this graph. So you see, what is the car doing? For the first part, again, positive gradient, positive acceleration. What does it mean by positive acceleration? That means the car goes faster. Faster, right? It's not like just now, just now this part, the car goes steady speed. Now it goes so you see, the graph looks the same. All right, the graph looks the same, but it's not the same, right? The motion is very different. And then for the second part, this is zero gradient, isn't it? Zero gradient. Zero gradient means zero acceleration. What does it mean by zero acceleration? That means you're not increasing your speed. That means you're still traveling at a steady speed, isn't it? You are still traveling steadily, isn't it? If your dad drives 90 on a highway, he keeps driving 90, his acceleration is 0. Okay, again, if your dad drives 90 kilometers on a highway, his acceleration is still 0. Right? So in this case, the velocity here, the velocity here is steady. Although the acceleration is 0, the car is still moving steadily forward. Whereas compared to just now, straight line means the car stops. Because 0 grade, the displacement didn't change, right? See, I stay my displacement at 50. So my distance is not increasing, my displacement is not increasing, I'm not moving forward. But you see, I stay my speed at 8. If I have a steady speed, I'm still moving forward. Right, guys? This part is more about understanding. It's more about understanding. It's not as, I mean, it's a little bit confusing, but it's not that hard. And then next, negative gradient, negative gradient, negative acceleration. What does it mean by negative acceleration? That means I brake my car. I step on the brake and my car slows down. I slow down my car. So when I slow down my car, I'm still moving forward, isn't it? When your dad slows down, you're still moving forward. So you see, I still move forward. So in this graph, you move forward faster, you move forward steadily, you move forward slowing down. So 3 part you move forward. Whereas just now that one, if something like this, you move forward, you stay, you move backward, you're back to 0. So displacement 0. This one is not. All right, so how do you find the displacement? You look at the area here. Okay, guys, if these two graphs looks very confusing to you, okay, you know what? Let's do some exercise first. I'll talk about that later. Okay, so in this case, when you see confusing stuff like this, okay, when you see velocity, now you have to write down. You have to write gradient equals to acceleration, area equals to displacement. Again, write this down. Like just now, when you see displacement time graph, you write gradient equals to velocity. Right? Now, gradient equals to acceleration, area equals to displacement. You write this down, you make your life easier. So what is the displacement of the ball in the first 4 seconds? So what is the displacement? How do you find displacement? How do you find displacement? You find the area, right? So the area for the first 4 seconds. For the first 4 seconds, the area here. So the area is 4 times 1, so it's 4 meter, right? Simple. Next, B, determine the acceleration of the ball from 8 to 12 seconds. So what is the acceleration? What is the acceleration? Acceleration is the gradient. So they want this gradient here. What's from 8 to 12 seconds? So this coordinate here is 8, 3. This is 12, 0. So 0 minus 3, 12 minus 8. Negative 3 over 4, negative 0.75 ms minus 2. Cause it's acceleration. Right? So remember to write this down. It makes your life easier. It makes your life easier. Right? So number 2, the velocity time graph below shows the motion of a motorcycle. So this is a motorcycle. Determine the velocity when time is 4 seconds. Velocity. So there's no need for you to calculate here. So 4 seconds. What is my velocity? My velocity is 10. Right? And then time, 8 seconds. 8 second velocity is 15. All right, easy peasy. So displacement, how do you find displacement? You find the area, right? The area between 0 to 10. So from 0 to 10, that means they want this area. Right, guys, do you know what shape is this? Anyone? Yes, it's a trapezium. What's the formula for trapezium? Do you remember the formula for trapezium? I mean, you can calculate this triangle first, then you calculate the square, but it's a very stupid method. It's very slow. So the formula for trapezium is 1 over 2 times. Right, Kavi, that's good. A plus B. I believe that's a typo. times C, isn't it? Okay, not plus C, is that a typo? Okay, so 1/2, A plus B is 4 plus 10, C is 15. So this will be 105 meter. Okay, so this part is not as hard as you think. Right, if you say, sir, this part I really can't remember. Area equals to displacement, gradient equals to acceleration, and then this one, gradient equals to velocity. All right, if you're scared that you will forget, I have a trick for you. This is what I use. All right, this is what I use. Can you see? Displacement divided by time is velocity. Velocity divided by time is acceleration. And the reverse is true. Acceleration times time is velocity. Velocity times time is displacement. Right? Whenever you go down, you're trying to find the gradient. Right? You see, displacement time graph, the gradient going down, the gradient is velocity. Right? You see, displacement time graph, the gradient is velocity. This is what I use. All right, and then for the velocity time graph, the gradient, because gradient is going down, the gradient is acceleration. See, velocity time graph, gradient is acceleration, and then area is going up. Velocity, gradient, sorry, area is going up. See, area what? Going up. So going up is displacement. So for velocity time graph, the area is displacement. So velocity time graph, the area is displacement. This is what I use. This is like my personal note lah. Like my own cheating note lah. Okay, you can use this, up to you. This makes my life better. If not, you just have to memorize it that way. All right, so let's move on, shall we? Let's do some exercise, shall we? So let's do some more. All right, number 3. So velocity time graph. What is the velocity of the trolley V at time 4 seconds? So they want the velocity. This is a velocity graph. So we just get it from the graph. So time equals to 4. When the time is 4 seconds, the speed is 10. So 10. Right? B, what is the time taken for the trolley to achieve V equals to 5? Right? When my time is 5, how long did it take? 2 seconds. Okay, so far so good. Easy. What is the acceleration of the trolley at the time interval between 0 to 6? Right? From 0 to 6, they want the acceleration. So what is the acceleration? Acceleration is the gradient. So we want this gradient here. So this is 6, 15. So 0, 0. So 15 divided by 6, you get 2.5 meter per second squared. Okay, I'm flying through, guys. If you have any doubt, please slow me down. Make sure you absorb, guys. Make sure you absorb. This part is a must score in exam. Because there's no explanation or whatever here. It's very easy. So what is the displacement of the trolley? Total displacement. So what is displacement again? That's the area. So you calculate the whole thing here. Okay, calculate the whole thing here. Again, trapezium. So 1/2, right, times 15 times A plus B. So A here is 6. B here is 12. So 6 plus 12. So this is 135 meter. Okay, I just count it inside my head lah. Done this long enough already. Okay, so what is the average velocity? Again, average velocity, you have to find the total displacement divided by time. So what's the total displacement? There, we have it just now, 135. And the time is 12. 12 seconds, what? So what's the answer here? This one I cannot calculate. This one I cannot calculate. So by estimate, this is 11 point something. Oh, 11.25, thank you. 11.25. Right, so far so good, guys. So far so good. Unfortunately, I cannot do more exercise with you. You know, these exercise behind, I can't do it with you because I don't have the time. Right, so go home, make sure you do all of it. If you're very weak in this graph, you have to do all of it. Right? I mean, you've learned this in maths before. If you know that you are weak at it, please do more exercise. The answer is already posted in Google Classroom. So please do it yourself and please check it there. Guys, this won't take you a lot of time. There's no writing or whatever here. It's just calculation. Right? It's just like doing maths, so it should take you very little time. Okay, you have 2 weeks of holiday, make good use of it. I mean, you say, "Hey, sir, I wanna relax this holiday." Yes, you can enjoy, but please do it in moderation, right? I mean, I'm a lazy person too. Okay, I like enjoying my own time too, but what needs to be done, lah. Right? Goes without saying, Anyway, let's look at 11.3. What is gravitational acceleration and free fall? Right. Before I move on, okay, let's talk about what is gravitational acceleration, or we know as G. This thing you kind of learn it in Form 2. What does it mean by gravitational acceleration? That means if you were to drop an apple from your hand right now, the apple will go through what we call gravitational acceleration, right? Right, imagine this. If you jump down from 18th floor, you go faster and faster, right? And that acceleration is what we call gravitational acceleration, right? It's the same everywhere on Earth. So our gravity acceleration, we call it G. G on Earth is 9.8 or 10. Some books, they round it up to 10. But the accurate value is 9.8. That means no matter where you jump, you get 9.8, right? You jump you jump in France, you jump in Germany, you jump in Thailand, you jump in Malaysia, wherever you jump, you experience the same acceleration, right? Because you're on Earth, unless you jump on Mars, right? So wherever you are, you will experience 9.8. Okay, so guys, let me ask you something. Let me ask you something. If you and your friend, let's say you are A, your friend is B, you guys jump down at the same time, you guys go through the same acceleration, right? Right? Because you both are on Earth, right? So do you guys reach the ground at the same time? Do you guys reach the ground at the same time? You guys go through the same acceleration. Do you reach the ground at the same time? Yes, right? Yes, right? You guys reach the ground at the same time, right? So you'll be dead at the same time, right? Okay, so I have another question. Let's say now you throw a piece of feather and you throw a stone, okay, a stone. You throw a rock. You throw a piece of feather and a piece of rock. Then do they reach the ground at the same time? Okay, now it feels weird, isn't it? Now it feels weird, isn't it? Do they reach the ground at the same time? You go KLCC, you throw a piece of feather down, will feather reach the ground at the same time as the apple? Oh, sorry, as the rock. Does it do that? Does it do that? Do they reach the ground at the same time? No, isn't it? No, isn't it? So how is this? Why you reach the ground at the same time as a friend, but how come feathers they can't? Huh? What gives? What gives? What's the real cause behind? Right? Some of my students say, "Sir, this doesn't apply physics law." No, physics always apply. You cannot break the laws of physics, right? So everything comes because, okay, let me ask you, if you were to go do skydiving today, you know what's a skydiving, right? Okay, if you go do skydiving today, what do you feel on your face? What do you feel on your face? When you're jumping down, what do you feel? Okay, air, right? Yes. Our key point here is the air resistance. Okay, it is the air resistance. So you see, a rock is very heavy. Okay, not pressure, it's the air resistance. Okay, close. Right, so you see, when you throw a rock down, does the air resistance affect the rock? Not as much. So the rock still falls down. But if you blow air resistance to a piece of feather, a feather is so lightweight. A feather is so lightweight. This air resistance, it slows down this feather a lot. Right? Right? So if we do this in vacuum, what will happen? Let's say we take out the air resistance. If we do this in vacuum, what will happen? Do they reach the same time? No, vacuum, as in empty, no air. If I take all the air out, there's no more air resistance. Will these two reach the ground at the same time? No, maybe. Right. If you take out all the air, there's no more air resistance, right? Two of these, they will reach the ground the same time. Okay, let me show you something. Let me show you something. Okay, let's look at, someone actually did this experiment though. Someone actually did this experiment though. Let me find you the GIF. I'll see if I can find you the GIF. Okay, so they did this with air first. Can you see that? Can you see that? They release bowling ball and feather. Can you see the bowling ball reach the ground first? This is with air resistance. This is, normal situation with air resistance. So the bowling ball ratios, I mean, common sense lah. Okay, according to our logic, the bowling ball will reach the ground first, isn't it? Right, but what if now I draw a vacuum? Okay, I'm not sure whether this is okay, this is not it. Okay, oh, this is not it as well. Sorry. Okay, I bet this is it. Can you see? They even slow down the motion for you. You see, the bowling ball and the feather, they drop at the same speed to the ground. You see, laws of physics still applies, right? Right? If there's no air resistance, you go through the same acceleration, the gravity acceleration, so you reach the ground at the same time. Wow, awesome, isn't it? Awesome, isn't it? So in this case, the vacuum case, in this vacuum case, we call it free fall. Can you see a vacuum here? Can you see a vacuum here? This case, we call it free fall. What does it mean by free fall? Free fall, that means there is only there's only Earth's gravitational force acting on the body. No air resistance. Okay? No air resistance. Right? Your object just flies through the air and reach the ground at the same time. This looks weird, isn't it? This looks weird, isn't it? If I don't show you the video just now, you wouldn't believe it. You're like, okay, the bowling ball and the feather will reach the ground at the same time. You're like, are you drunk? What? No. You must be thinking the person is crazy. But hey, that video was not edited. Just to let you know, this is free fall. But you don't see free fall on Earth because where can you find vacuum on Earth? Right? You don't say, okay, I'm going to kill myself today. I better kill myself in a vacuum chamber by jumping down. There's no such thing, right? And space, okay, if you go space has no gravity. Right? So free fall doesn't apply. Free fall doesn't apply. So the normal case just now, the one that without a vacuum, the one that's without vacuum, the bowling ball drops first. Like in this case here, this is a non-free fall. Because there's air. Because there's air. Because there is air resistance. So now that's why the feather slows down. That's why the feather slows down. So theoretically, if we throw, guys, free fall, here's the amazing thing about free fall. In free fall, I don't care whether I throw a strand of hair, or I throw a bacteria, or I throw a piano or a car, they will reach the ground at the same time. Wow. You see? So physics law, they always apply. You cannot break the laws of physics. Right? It is physics for a reason. So the more you know, isn't it? Next year, okay, sorry, not next year. I mean, if you go physics, you'll be learning this lah. But okay, you get the point lah. You get the point lah. Yeah, so this one is a free fall, and this is a non-free fall. If you go parachuting, if you go for skydiving, it's a non-free fall. right? Because you see, up when they do skydiving, right, they can kind of glide in the sky, isn't it? They can just open themselves, they can just hang out in the sky like that. That's because of the air resistance lah. If there's no air, if it's free fall, you jump down from a plane, you will fall straight down. You'll smack right on your face. Even if you open your parachute, the thing won't slow down. You get what I mean? You see, when you do skydiving, when you are nearing the ground, you open your parachute, right? When you open your parachute, you increase the air resistance like the feather, so you slow down. You don't kill yourself. But in a free fall, you open a parachute, you just keeps going down. I don't care. You go the same speed down, the parachute doesn't work. But then again, it doesn't exist, isn't it? There's no such thing as vacuum in this world, right? So it doesn't apply. Okay, so I hope you get what I'm trying to say here. Very interesting stuff, isn't it? Right, so this graph here, I'm not going to tell you how to draw because this is very confusing. I will leave it up to you. All right, because even if they ask this in an exam, it's going to be a 2-mark question and it's not necessarily coming out. And this takes me a lot of time to teach. So, I'm just going to leave it. Right, the next one, please put a star here. This inertia, almost every exam you will see them. Okay, good thing here, guys. Good thing here. There's no calculation here, and there's nothing to memorize here. So what is inertia? What is an inertia? Have you heard of this before? I'm sure your school taught this before, right? Yeah, taught this before you go on holiday, right? Okay, so what is inertia? Inertia, do you understand what is your school saying? What did your school say to you? So it is a tendency of an object to resist any change in its original state. Please add of motion. Okay, of motion. The tendency of an object to resist any change in its original state of motion, right? If you still don't understand, sir, I catch no ball here, don't understand, right? How do I teach kids on inertia? Okay, you guys are kids. Okay, so things at rest, they like to stay at rest. And moving things, they like to stay moving. You get what I mean now? All right. Okay, so what do I mean? If you have if your car broke down, if your car breaks down in the middle of the road, you want to push your car, it's gonna resist you pushing, right? You don't just push your car effortlessly, isn't it? You want to push your car, it has some sort of resistance to it. Your car refuse to stop. Refuse to move, right? And the other opposite, if your car rolls down a hill, okay, if your car rolls down a hill, would you try and stop it? No, you don't, right? You want to stop it. Oh my God, you cannot stop it. There's a resistance in stopping it. So this resistance that the car refuse to change, the car at rest, the not moving car says, I don't want to move. And then the moving car says, I don't want to stop. The resistance to change is called inertia, right? So can you see now? Things at rest stay at rest. Your car that is not moving, it doesn't want to move. Moving things stay moving. The car that is moving, it doesn't want to stop. Right? So it's like the resistance towards change. Right? Guys, have you heard of what is sleep inertia? Okay, sleep inertia. We all go through this. In the morning, you're asleep, right? You don't want to wake up. Happens to all of us, okay? In the morning, especially school, you just don't want to wake up. Right? So it takes a while for you to wake up, isn't it? Your alarm rings, it takes you a while to open your eyes, it takes a while to wake up. You can't just pop out of the bed in 1 second. No, right? This is what we call sleep inertia. And then at night, you refuse to sleep. Right? You know you should sleep at 12, and then 12 you're still watching drama, you're like, I don't want to go to sleep. You see? This is sleep inertia. When we are sleeping, we don't want to wake up. When we are awake, we don't want to sleep. Same as the car lah. Same as the car. It's all of us, Gabi. It's all of us. I shamefully can't admit how many times it has happened to me. We all go through that. Okay, just one more scroll on my Instagram, I will sleep. I swear. And the next moment you look at the clock. Oh my God, it's 2 a.m. Right? So inertia, isn't it? Inertia lah. Right? So things at rest, they stay at rest. Moving things, they stay moving. right? So this is same as the car. So here's the thing, guys. The larger the mass, is it mentioned? Okay, so the larger the mass, the larger the inertia. If your car, okay, it is very to push a bicycle, very easy to push a bicycle, very easy to stop a bicycle. But it is very hard to push a car, also very hard to stop a car. So this is what I mean by larger mass, larger inertia, right? So inertia happens when, okay, let me explain about the bus thing. Right. You see, when you board a bus, when you're sitting on a bus, a not moving bus, let's say standing, like okay, standing. Okay, you're standing on a bus, the bus is not moving, you are not moving, right? Both of you are not moving. When the bus starts moving, when the bus starts going forward, you don't want to change. You don't want to change. You want to stay at rest. You want to stay at rest. So what do? You go forward, right? The bus is trying to move forward. You say you don't want to move, so you go backward. So that is inertia, right? You are at rest. You want to stay at rest, so you go backward. Okay, and then now when the bus gets moving, you are moving. Okay, the bus is driving down, you are moving also. And then when the bus stops, you don't want to stop. So what do? You go forward. Right? When the bus suddenly brakes, you just lurch forward. Inertia lah. Inertia lah. When you are at rest, you want to stay at rest. When you are moving, you want to stay moving. So that is inertia. Right? So this is a theory. This is a law of physics. There's no calculation here. This is just a phenomena that you should know. So that's your inertia, right? So as you can see, who is heavier? Tin B is heavier, right? So this tin B, it is very hard to push this thing moving. Very hard to push this thing. Also very hard to stop this thing. You get what I mean? This thing is hard to start swinging, hard to stop swinging because the inertia is too big. This is like a lorry. This is like a car. You want to push a car moving, it is much easier. You want to stop a car, also much easier. Lorry, very hard to start moving, very hard to brake. Okay, I hope you guys understand this. Right, so effects of inertia in daily life. We have positive effect and negative effect. Sometimes inertia is good. For example, tightening your hammer head. Right, what does it mean? You know, okay, I'm sure most of you never used a hammer before. Okay, this hammer, the head always comes loose. All right, so instead of you pushing it back to tighten it, no need. You just bang the hammer on the table. You know why? Because when you move the hammer, the head moves together. When you stop the hammer suddenly on the table, the head wants to keep moving. The head has inertia. So it will go down and you tighten the hammer head. Okay, using your back, you don't need to push like that. Just bang it on the table. So this is inertia. And of course, spinning the umbrella. When you spin your umbrella to the left, the raindrop goes to the left. When you suddenly change to the right, the raindrop wants to keep going left, so the thing will be wee, it will swing off from the umbrella. It will swing off from the umbrella. Right, next, ketchup also. When you swing your ketchup bottle, the ketchup moves together. When you stop the bottle suddenly, the ketchup wants to keep moving, so it splashes out from the bottle. Okay, easy, huh? No calculation here, it's just explanation. Right, so a negative effect. So an airplane, since it's very heavy, it has very large mass, so it needs a long runway to brake. Okay, that's why touching down is a challenge because the inertia is very big, and of course, inertia can cause you to get injured. That's why you need airbags, you need headrest, you need safety belt. Guys, this thing is more important than you think. This headrest, this thing is not for your comfort. It's not like, oh, you can lie down driving, this feels comfy. No. This thing is to prevent that inertia because when you go backward, if there's no headrest, you can snap your neck. Right? Imagine the chair is only until here. You snap your head backwards, you can die on the spot. So this thing is more important than you think. This is not for your comfortness. This is not just for comfy one. This is to save you from the neck. Right? And for very big oil tanker like this, they need to brake their ships. They need to stop their ship 10 kilometers away from the port. Right? That means 10 kilometers before they reach the port, they have to shut down their engine so that they can just nicely stop at the port because they have super big inertia. They are too heavy. So they have to stop in time. Right? So how do we reduce negative effect of inertia? Okay, we use seat belt, like I said. We use airbag, right? And we use steel structure like here. so that when I brake this car, when I brake this lorry, this timber doesn't just fly forward and break you into half, right? And of course, you have compartments in your oil tank, okay? Instead of, right, you see, this is my water bottle. When I have one big compartment, can you see this water slosh around? Okay, when I brake my lorry, can you see this water slosh in front? And it might push my lorry forward. So to stop this from happening, I split this into a few compartments so that the water doesn't splash around. So your lorry will be safer. Right? So you guys get it, huh? You guys can understand, huh? This is a really easy chapter, so yeah, nothing much to say here. All right, so hey, we have 10 more minutes. So let's do some exercise, shall we? Let's do some exercise, right? Let's do the graph one lah. Let's do the graph one, see if I can cover anything. Let's go to question 10, shall we? This is page 22. Page 22. So this is a displacement time graph. When you see a displacement time graph, again, write down the gradient. The gradient is velocity. Okay, remember this, displacement, you have velocity, you have acceleration. Going down is the gradient, going up is the area. Right, since it's a displacement time graph, okay, going down, the gradient is the velocity. The area doesn't mean anything. There's no area. Because displacement, you go up, there's nothing. So this is the velocity. So describe the route of the, okay, I'm not going to describe, I'm just going to do the calculation. So calculate the total distance. See, they want the distance. That means how much they travel in total. Although this thing ends up at the same point because the displacement is 0. Because I start at here, I end here. So 0. So I move forward for 8. I move backward for 8. So that's 16. I move backward for further 8. So that's 24. Move forward for another 8. So that's 32. Right? So this is the total I travel. Distance is the total. So what is the velocity of at the first 2 seconds? Wow, they even give you tips already, gradient. So first 2 seconds is here. So we want the gradient of this. So this is 2, 8. So 8 divided by 2. So 4 meter per second. You pray that your exam is going to be this easy lah, but I doubt so. This is too easy. Maybe in objective, maybe. So what is the final displacement? Like I said, is 0 because they start at the same point and they end at the same point. Right? So C, D, what is the average velocity? Again, average velocity, just take your total displacement divided by time. What's the total time? The total time is 8. Whatever lah, 0 divided by 8 is 0 lah. So 0 average velocity. So F, what is the velocity of the object from second to 6 second? That means from here to here. That means from this whole thing, from here to here. This whole thing. So this is 2, 8. This is 6, negative 8. Right? So negative 8 minus 8. And then 6 minus 2. So you get negative 16/4. So you get negative 4 meter per second. So this whole thing is negative 4. Okay, easy, huh? Easy, huh? So let's do one with the velocity one. Okay, so this is a velocity time graph. Just nice. So for velocity time graph, the gradient going down, the gradient is acceleration. The displacement, okay, is the area. So the area is the displacement. The gradient is the acceleration. Okay, so determine the initial acceleration. Initial acceleration, that means here, this part lah. That means they want a gradient here. So this is, oops, this is 10, 8. So 8 divided by 10. Right, so you get 0.8 meter per second square. Calculate the average speed. That means they take the total distance divided by time. So what's the total distance? Just calculate your total area here. This is a bit fussy, this question. So 1/2 times height times A plus B. Okay, so this one is for here. And don't forget we have one more here. So plus 1/2 height times base. Okay, because this is 10 here, and this is 4 here. So this would be 140 plus 20, so 160. So the total distance is 160. So 160 divided by the total time. The total time is 40 seconds. So you get 4 meters per second. Whoa, this is a long question. This is seriously a long question. So calculate the displacement. So what is the displacement? So you see, this is the distance. But how do you calculate the displacement? Okay, very easy. The top part of this graph, this is moving forward. Right? The bottom part, this part is moving backward. Right? So you take the forward part, you minus the backward part lah. That means 140 minus 20. So you get 120. All right, because I move forward for 140, this area here is 140, this area here is 20. So I move forward for 140, I go back for 20. So the displacement is 120. All right, displacement, distance is 160. Oh, I should be doing this first. So this is 160. Oops, sorry. So calculate the average velocity. Average velocity, I use displacement. So 120 divided by 40, I get 3 meters per second. So can you see distance and displacement, velocity and speed, they are same but different. Okay, you guys can understand this? This question is a bit hard. This question is, I wouldn't say it's hard, but it's challenging. If it comes out in exam, many people will die. Truth to be told. We'll try to understand. Kavi, that means you don't understand. Okay, which part do you need me to explain? Any? Cause area is the displacement. Not some words. Oh, you're confused between displacement and distance, isn't it? Velocity and speed, isn't it? Okay. This takes practice. I mean, this takes practice. Right? As long as you understand the concept, it's okay. Okay, the rest of it, I leave it up to you to differentiate. Okay, so anyway, we'll do a lot of practice. Yeah, sure. Please do. Right. We have like 2 minutes here, so I'm gonna leave it here, guys. I don't, I don't want to say that, oh guys, this holiday you should study. I know many of you won't. Right? I just want you to at least finish this exercise. Okay. If you say you are too lazy to write things, then you at least do the calculation one lah. Like I said, the answer is already in Google Classroom. So do this and check the answer. Right? While you're at it, also please also revise the previous few chapters. Okay? And please request video for chapter 12. I'll send you chapter 12 and watch that too. And please do revision. Okay? Week 2 and week 4. Oh, I sent you week 2 already, Kavi. I sent you week 2 already. Or week 4, I will send you later. You requested, right? Okay, I remember. I'll send you week 4 later. I'll send week 4 later. Please check your Google Classroom. I sent it there. Okay, I sent it there. Right, so I'll leave it up to you to revise lah. Please make sure, I mean, you can enjoy this holiday, okay? Because the next 2 weeks is gonna be a holiday. Do enjoy, but do enjoy in moderation. Okay, do some revision. All right, so this would be the last time me seeing you this year. Right, I'll be seeing you next year. Hope you have a Merry Christmas and a Happy New Year. I'll see you in 2023. Right, do take care of yourself. I will see you soon. Okay, so all the best. Good night to you. I will see you. Bye bye. Bye bye.